wisteria in the corner? No, won't work. How about a shrub? Oh. Hello, Math Shop. Christine speaking. Oh, hi, Sylvie. Yes, today is the big day. Yeah. Oh, listen, thanks for the grass seed. Yeah, no, I saw it when I came in. Well, I'm just kind of worried. Like, do you think it's going to be enough? I mean, we're doing the whole front lawn and everything, and I'm thinking about...
The truck's here.
I have to... Okay, great. I have to call you back, okay? Okay, thanks again. Bye. It was my cousin Sylvie who gave us the grass seed. What happened to the hose?
The lawnmower did it.
Oh, the lawnmower did it. Was it a suicide or a murder?
Hey, so I made a little mistake. I mean, it could happen to anyone.
Okay, coming! Hi, and welcome to the Math Shop, the home of living better mathematically. I'm Christine, and this is my partner, Kanwal. And this is my home-built, super powerful, and, well, sometimes humorous computer, Euclid. And today we've got a really great show for you, all about perimeter, area, and volume, but, okay, all right, but today the show starts outside, so come on.
You Christine?
Yeah, you got my topsoil?
I sure do. Where do you want it?
Right here in the driveway would be great.
You got it.
Great. Okay, here's the deal. As part of our never-ending search for beauty and order in the universe, we here at the Math Shop have decided to do some landscaping. First of all, what we're going to do is put a wooden border all the way around the lawn, and I've already bought the lumber for that. And then we're going to dress the lawn with some topsoil. We thought it would, lead nicely into our topics for today, which are perimeter, area, and volume. I hope there's enough room in this driveway for all this dirt. I gotta cover the lawn to a soil depth of 10 centimeters. It's a lot of soil, you know.
Okay, then stand back.
Oh, and I got this tarp back here to cover it up just in case it starts raining before we can spread it around.
Okay, there's your dirt. Sign here.
There's my dirt? What are you talking about? I didn't order that.
200 cubic centimeters, #1 topsoil, no weeds. That's what you ordered. That's what you got.
Yeah, but I need enough dirt to cover this entire lawn.
We got your fax order right here, ma'am. Are you gonna sign or not? I got more deliveries to make.
Yeah, okay, I'll sign.
Here.
So, how much do I owe you anyway?
That's 6509.
What? 65 of what?
6509. 9 cents for the dirt, including tax. $65 for the delivery. And that's a bargain at what it costs to run this truck. Give us a call if you're going to need some more.
And it looks like you will. See ya.
Kanwal, what went wrong?
I think I know, Christine. Let's go inside and talk about it. Oh, did you want to put the tarp over the dirt? I think it's gonna rain.
Oh, ooh, my ribs, that was so funny.
Okay, let's go.
I don't get it. I mean, I worked out the amount of soil and the lumber we'd need on Euclid. And then that's it. It's Euclid's fault. Maybe it's some sort of faulty FPU chip or something.
Hey, wait a minute, Christine. It might be Euclid's fault. Let's work through the problem and see.
Well, okay.
Okay, but the lumber hasn't been delivered yet, So let's do that problem first, in case we've made another mistake, and then we can get to the dirt later.
All right. Euclid lawn plan, please. And I know these measurements are accurate.
Good. Now, we want to put a wooden border around the perimeter of the lawn, right?
Right.
The perimeter is just another way of saying the distance around the outside of something. And in this case, there are two ways of calculating the perimeter. In the first method, we add the lengths of each side. But there are two dimensions which are unknown. One on the extreme west side, which we can call W, and one on the southern side of the lawn, which we can label S. So, the perimeter could be expressed in this equation. P equals S plus W plus 6.15 plus 4.75 plus 1.8 plus 2.2. I'll calculate W first. By looking at the diagram, I know that if I add W and 2.2, the answer will be 4.75. The equation is W plus 2.2 equals 4.75, or W equals 4.75 minus 2.2. So W equals 2.55 meters. I can solve for S in a similar way. S plus 1.8 equals 6.15. S equals 6.15 minus 1.8. So S equals 4.35 meters. And now I can substitute these values for S and W in the original equation, which gives me this. I then add up all the terms, and that tells me the perimeter of the lawn, which is 21.8 meters. Is that what you got?
Yeah? No. I don't know. Where's that printout? I have a printout somewhere.
Okay, well, while you're looking for the printout, Christine, I'll show the audience the other way of calculating the perimeter. Euclid, lawn plan again, please. This method involves a little insight.
If you look at the diagram, you might notice that by moving the two interior sides out, we can form a rectangle.
Remember, I'm computing perimeter here, not area. So moving these sides doesn't affect our calculations. Now I can use the following formula, which is the usual formula for the perimeter of a rectangle. P equals 2 times the length L plus 2 times the width W. I substitute for L and W, and then do the calculations. And I get the same answer, 21.8 meters.
That's what I got.
You calculated the perimeter is 21.8 meters?
Yes, but that's not the amount I ordered.
No.
No, I ordered more lumber in case of wastage and mistakes. But now let's do the volume of soil, Kanwal. I've got my calculations right here, and I'm going to follow along as you go. Euclid, lawn plan again, please.
Well, let's see. We decided that the lot needs 10 centimeters of new topsoil. This is really a volume problem. Because we are looking for the amount of soil that will fill a shape which is the size of the lawn and 10 centimeters thick. The formula for calculating volume is V equals base area times height. In this case, I know the height is equal to 10 centimeters, but I still need to know the base area. So, I'll begin by calculating the area of the lot. If the lawn was rectangular, this would be easy. The formula would be area equals length times width. But as you can see, the lawn is L-shaped. And so there are really two areas to be calculated. I'll label them area J and area K. By drawing this extra line, Euclid has formed two separate rectangles. And I can now find the areas of both of these and then add those numbers to get the total area for the whole lawn.
Yeah, that's what I did too.
Well, so far so good then. We already know the dimensions of rectangle K, so I'll begin here. rectangle K is 2.2 meters by 1.8 meters. So, the area of K is 2.2 times 1.8, which equals 3.96 square meters.
I got that.
Good. Now I'll find the area of J. I know that the long side of rectangle J is 6.15 meters. And from our perimeter calculation, I know that the short side is equal to 2.55 meters. So now I can say that the area of J is 6.15 times 2.55, or 15.68 square meters, to the nearest 2 decimal places.
That's exactly what I got.
If we add the areas of K and J together, I get 19.64 square meters.
Precisely.
So now for the volume. Do you remember the formula we stated earlier? Volume is equal to base area times height. Now we can substitute in the values. And I have volume equals 19.64 square meters times 10 centimeters. But Christine, I think this is where you, or Euclid, went wrong. See, right now the equation has different units, centimeters and meters squared in it.
Right.
And you have to convert one or the other, so they are the same.
I didn't do that.
I thought so. See, if you multiply these figures, you get a result of 196.4. You might decide to label that figure as either cubic meters or cubic centimeters, but either one would be wrong.
I can't believe I missed that.
Oh, it could have turned out worse. You labeled the results as cubic centimeters, and you only got a handful or two of dirt.
Yeah.
If you had labeled them as cubic meters, you would have got 196 cubic meters, and we would have had a whole fleet of trucks out there, and we could have had enough soil to build a pyramid on top of Math Shop.
Oh, that makes me feel a lot better.
Oh, don't feel bad. Just another little mistake. Could happen to anyone. But it just goes to show that units are very important in such calculations. When faced with different units, make sure you convert them to common units of measure before making any calculations. Euclid, could we see the equation again, please? In this case, I must either change the centimeters to meters or the meters to centimeters. Because large amounts of soil are usually ordered in cubic meters, I'll convert the centimeters to meters. 10 centimeters is 0.1 meter. And now, if I do this calculation, I get 1.96 cubic meters. So you should have ordered 1.96 cubic meters of topsoil, say 2 cubic meters, not 200 cubic centimeters.
I'm absolutely mortified, Kanwal.
Oh, you don't have to be. You're not the first person to make that mistake. Don't you remember some years ago there was this jet plane flying over Manitoba and they ran out of fuel and the pilot had to glide it in for a landing?
Yeah.
That's because someone forgot to convert the units of measure.
Well, I certainly hope I've learned my lesson. Well, now let's review the concepts of perimeter, area, and volume. Perimeter is the distance around an object. There's just one dimension, length. And it could be measured in any unit of length, such as meters, for example, or centimeters. Area refers to the surface covered by an object. Because it's usually determined by the dimensions of length and width, we call it two-dimensional, and it's measured in square units, such as square centimeters. Volume is dependent on 3 dimensions: length, width, and height. We call it three-dimensional. It measures the space occupied by an object and is expressed in cubic units. For example, cubic centimeters. However, life is not a bowl of rectangles. Now, when you're faced with finding the area and volume of other shapes, such as triangles and circles and cylinders, you need other techniques. What's this?
Sunglasses. Remember we're going to the beach?
The beach.
Yeah.
Oh, the beach. The beach. Okay, great. Euclid, a little beach ambiance, please. Ah, perfect. Now, if Euclid could only make a few pina coladas, huh? Yeah, that's what I thought. Look, the sun, the surf, the sand.
Oh, you'll be cleaning up today.
Oh, look, a sailboat.
Exactly. And the area of a sail?
Well, since it's a triangle, it's 1/2 base times height.
1/2 base times height. Let me show you why this formula works. Euclid. The formula will work with any type of triangle. First, it has to be labeled. I can use any side as the base. If this side of the triangle is the base, that makes this distance the height. But now, let's draw a rectangle around the triangle. If you look carefully, you'll see that the height of the triangle splits the rectangle into two smaller ones. Let's start with the larger rectangle on the left. Notice that the rectangle is split in half by the side of the triangle. Now look at the smaller rectangle on the right. The side of the original triangle also splits this into two equal pieces. Therefore, you can see that the triangle is actually half the size of the rectangle we have drawn around it. So the area of the triangle must be half the area of the rectangle. As you know, the area of the rectangle is L times W, so the area of the triangle is L times W divided by 2. In this example, the length is equal to B, and the width is actually the same as the height, so the resulting formula for the area of a triangle is A equals B times H over 2, or A equals 1/2 B times H. And that works for every triangle.
Okay, thanks, Euclid. Kill the surf. Oh, I think this is Euclid's way of bringing up the topic of circles. Give us a circle we can work with. The perimeter of a circle is often referred to as the circumference. The perimeter and the circumference mean exactly the same thing. And as you might expect, there's a formula for calculating the circumference of a circle, which is C, the circumference, equals 2 pi r, where r is the radius of a circle. Now you may be saying, how'd I get that?
Well, let me explain. Pi is a Greek letter that represents a constant. That means it is the same for every circle, no matter what the size is.
It's derived from the relationship of the diameter and the circumference of any circle, like this. When the circumference of any circle is divided by its diameter, the result is always equal to pi, or approximately 3.14 to 2 decimal places. I'll get Euclid to show you how this works. Euclid, now wrap the diameter around the first circle as many times as possible. Okay, 3 times. How much of the circumference is left uncovered? So, the diameter of a circle can be divided into the circumference 3.14 times. That's pi. Check this with the other 2 circles, Euclid. No matter what size circle, the circumference divided by the diameter is always equal to 3.14 or pi.
If I now manipulate this equation, using the laws of algebra, you'll see how we arrived at the formula for the circumference of a circle. We know that circumference divided by the diameter is equal to pi. I multiply both sides by d. Therefore, we can also say that C equals pi d. Since the radius is half the diameter, we can also say C is equal to 2 pi r. This is the most convenient way of writing the formula for finding the circumference of a circle, because we will more often know the radius of a circle rather than its diameter.
Knowing the circumference of a circular object has many practical uses. For example, your car's tires and their size are directly related to the car's odometer and speedometer. As the size of a wheel increases, so does its circumference. The number of wheel revolutions times the circumference of the wheel equals the distance traveled. In this example, for every revolution, the wheel travels 1.1 meters. The wheel revolves 1,500 times. It will travel 1,650 meters, or 1.65 kilometers, as shown on the odometer. Now let's see what happens when the wheel diameters are larger. The larger the diameter of the wheels, the farther you'll travel using the same number of revolutions. On the other hand, a speedometer measures speed. Using the number of wheel revolutions per minute, the speedometer will display the vehicle's speed. Both the odometer and speedometer must be calibrated to the size of tire on your vehicle so that they give accurate readings. So knowing how to calculate circumference can be very important.
You've learned how to calculate the circumference of a circle, but to calculate the area of a circle, there is a different formula. Area equals pi r squared. Let me show you how we get this formula using a pizza pie. But seriously, we know that the circumference or the distance around a circular pizza will be c equals 2 pi r, and half the circumference will be pi r. Now, watch this. As you can see, I have rearranged the pizza so that it is now more or less a rectangle. The opposite sides are equal. If we cut it into more slices, we would get even closer to a true rectangular shape. And what are the dimensions? The short side of the rectangle is equal to the distance from the center of the pizza to the edge, or in other words, the radius. And the long side is the same as half the circumference of the pizza, or pi r. So the area would be r times pi r, or area equals pi r squared. Do you want some pizza, Christine?
Maybe later. I'm
Okay.
trying to pick a winner in the 6th. Skidooing girl? No knickers? Hot ginger. That sounds good. Anyway, here's a problem you can try using what you know about perimeter and area. Euclid, show us Clover Glen Racetrack, please. A local racing authority contacted the math shop for some help. They're going to rebuild their track, and the plans call for fencing around the outside of the track and new sod for the infield. They gave us these dimensions and asked us if we could tell them how much fencing and sod will be needed to complete the renovation. The fencing goes around the outside of the track, and that means that we're finding the perimeter of the track. To do that, we have to find the distance on both straightaways and the distance around the 2 half circles with radii of 70 meters. Each straightaway measures 200 meters, so 200 plus 200 equals 400 meters. As for the 2 half circles, together they form a whole circle, and the formula for the circumference of a circle, as we know, is 2 pi r. When we substitute into that equation, we get 439.6 meters of fencing for the semicircles. When we add the figure for the straightaways, we get a figure of 839.6 meters of fencing. So let's say around 840 meters in round figures. The sod problem is really one of area. So we have to find the area of the 2 semicircles at the ends and the rectangle in the middle. The area of the rectangle is 200 times 120, or 24,000 square meters. The 2 half circles form a whole circle, and the formula for the area of a circle is A equals pi r squared. Substituting into that, I get 11,300 square meters of sod for the semicircles. So the total area of the infield is 35,300 square meters. And this time we got the units right, too.
Oh, good. Now that you know how to calculate the area of a circle, you can also calculate the volume of a cylinder, which is what these cans are. The volume of a cylinder is found by multiplying the area of the base, which is a circle, by the height. What is interesting is that cans of different cylindrical shapes can have the same volume. Euclid, give us the can problem, please. Let's work out the volumes of these two cans and see how they compare. We can calculate the area of each base using the formula A equals pi r squared. And now that I know the area of the base, I can calculate the volume by multiplying the base area times the height. And it turns out that these two cans, which appear quite different, have almost exactly the same volume.
They have the same volume, but it's important to remember that they don't have the same surface area. Now these two cans, made from the same material, also have the same volume, but because of their shapes, one has a bigger surface area and therefore uses more metal. This one. I forget. This one. Obviously, there's an environmental side to this. Manufacturers would like to use the least amount of materials in making a can. And the less you use, the less there is to dispose of once the can's been used. And hopefully reused. Now let's look at the formula for calculating the surface area of a cylinder and try to find the optimal surface area of a can. Euclid, a sample can, please. The surface area of any cylinder is composed of its top and bottom and its side, which is really a rectangle. Now, using the formula for each of these components, I can say that the formula for the surface area of a cylinder is A equals 2 pi r squared plus 2 pi r h. Let's get Euclid to calculate a chart for a range of values for r and h and a constant volume of 1 liter. Now, any of the dimensions that Euclid is displaying will give us a can with a volume of 1,000 cubic centimeters or 1 liter. However, the first line, with a radius of only 1 centimeter and a height of over 3 meters, has a very large surface area. So does the bottom line, giving dimensions for a very wide, flat can. As you can see, a 1,000 cubic centimeter can that is 10.5 centimeters high and has a radius of 5.5 centimeters uses the least amount of metal. But that wraps up our show on perimeter, area, and volume. So next time when...
There's one thing you didn't wrap up, Christine.
What?
Your dirt. Don't forget the tarping.
Oh, keep rubbing it in, Kanwal. Oh, but while we're talking about mistakes, let me say that making errors in mathematics is expected, okay?
Okay.
In fact, it's part of the learning process. When you make a mistake, you know you've learned something worthwhile.
You're right, Christine. Not converting units is a mistake that everyone makes at some time.
Right. Okay, we've got to go, but thanks for watching and tune in again next time to watch The Math Shop, where mathematics can solve any problem, even the ones we make ourselves.
Goodbye.
Bye. Oh, that's for me. Hello, Math Shop. Oh, hi, Mark. How are you? Oh, listen, are you still into bonsai tree, planting, that kind of thing? Oh, you clear cut it? Oh. Oh, well, okay, well, oh, miniature farming. That's interesting. Like what? Well, how do you get the saddle on it?